What you see here today is a plug-in hybrid fuel cell bus that runs on hydrogen gas. The bus is part of a technology demonstration program with the Texas Commission on Environmental Quality. And it's also part of the National Fuel Cell Bus Program, which is sponsored by the Federal Transit Administration. The goal behind the research we're doing here is really just to advance commercialization of these new technologies and to kind of evaluate them, see where improvements may be needed, where advancements are needed. It's all about new technology and getting it on the road and seeing how it can benefit transit applications and transit authorities.
My work on it right now is doing vehicle modeling and analysis of this vehicle on routes in Austin. We're going to use these models to evaluate how effectively this bus runs over certain routes in Austin. Right now we're at the point of doing test runs where we're driving the bus on certain test routes within Austin, using the data from the bus to correlate computer models, and then from those computer models we'll be able to kind of go through and do more predictive estimations of how will the bus perform if you put it on this route or the Lamar route, etc. That'll allow services like Cap Metro to be able to decide if they want to use the bus on this route, how effective will the bus be on that route, and kind of give them better guidance of the bus's true capabilities.
What we're trying to prove out here is what's the best approach for these new electric bus technologies. Are you better off going with architecture you see behind me, where the fuel cell is on the bus and acts as a range extender, which slowly charges the batteries throughout the day? Or are you better off doing the fast charging on route? That of course has implications on the life of the batteries, and so ultimately it's what makes the most economic sense for the transit authority. The intended purpose for the bus will be one of the campus routes on campus, the UT shuttle routes on campus, possibly something like the Red River route or the Intramural Fields route. Right now it's in its testing phases. We're kind of shaking it out, making sure all the nuts and bolts are tightened and it's ready for actual passenger service use. Last thing Capital Metro wants to see is some problems in the field. But so far it's running well, and we're planning to get it out on the street soon.
Welcome to the Hydrogen Hybrid Bus. The Hydrogen Hybrid Bus is unlike any public transportation in existence today. Officially titled a dual-drive, battery-dominant, hydrogen fuel cell bus, the Hydrogen Hybrid Bus runs on a combination of electric battery drive and a relatively new concept, the hydrogen fuel cell. The hybrid bus is manufactured of a special composite fiber, similar to the famous Corvette sports car. The lightweight construction is a firm departure from traditional bus technologies. The hydrogen hybrid bus is powered 100% by electricity, mobile electricity. One thing you may have already noticed about the hybrid bus is it's quiet, much less noisy than other buses. That's because the main source of power for this vehicle is not an internal combustion engine burning gasoline or diesel fuel to generate movement, but rather a high-powered, compact, electric drive system that runs on a bank of batteries located in the bottom of the bus. The batteries store electricity that the bus uses to climb hills and drive around town. But the bus also regenerates or repowers the batteries with electricity generated from braking. The energy used to slow the bus as it travels downhill creates electricity that is fed back into the bus batteries. This gravity-assisted power generation is called regenerative braking, and it represents a significant breakthrough in energy conservation. The bus also restores electricity through its onboard hydrogen fuel cells. A hydrogen fuel cell is a relatively new invention that, like a battery, uses chemical energy to generate electricity. The fuel cells on this bus use hydrogen and oxygen atoms to generate electricity. The hydrogen atoms are combined across a semi-permeable membrane with oxygen to form water vapor molecules. The chemical reaction that ensues produces surplus electrons at a measurable, controllable rate that generates electricity. The electricity is then stored in the batteries. The fuel cell is a renewable energy resource. Hydrogen is one of the most abundant elements on the Earth. and there are many sources of hydrogen. The fuel cell chemical reaction produces no toxic waste products, only water vapor. The hydrogen used in the fuel cell is stored on this bus in composite fiber storage tanks on the bus's roof. And the bus tanks are topped off every morning before the bus starts its run. What else is special about this hybrid bus? It plugs in. At the end of the day, the bank of bus batteries are fully recharged by plugging it into an electrical charging service system at the garage. It takes several hours to fully recharge the bus, depending upon the demands of the fuel cell and the amount of regenerative braking applied during the day's operations. Another advantage of this bus is that its hybrid configuration allows for the replacement of various types of auxiliary power units that use other types of energy. While batteries power the main propulsion of the bus, all other services of the bus can be powered by hydrogen fuel cells, hydrogen combustion, natural gas, methane, ethanol blends, or in some cases, even diesel or gasoline generators. This flexibility also offers maximum use of the bus in nearly every area of the United States or even the world. You may have also noticed, besides the quiet powertrain and the composite fiber body, the hybrid bus has many additional beneficial features, including easy exit windows, a lower entry profile, and a unique GPS-coordinated information system that can tell you and the driver exactly where you are and when the next stop is. We hope you have enjoyed your tour of the Hydrogen Hybrid Bus. If you have any questions, please contact us at www.hydrogenhybridbus.com.
The Center for Electromechanics' Vehicular Active Suspension Technology, the legacy technology applied to the NASA Vibration Isolation System, substitutes smart actuators for normally passive shock absorbers or dampers, and adds sensors and a digital controller to provide unparalleled mobility over all types of terrain, while maintaining superlative vehicle stability and ride quality. In partnership with government and industry, the Center has successfully developed active suspension systems for a wide range of military and commercial vehicles, including Humvees, tactical trucks, tanks, transit buses, and other commercial applications.